Alright, so for this problem, we're trying to find the average shearing stress in the pin at point B. So that's this pin right here. So I'm going to go ahead and draw a picture of this from this side over here, looking on towards the handle. So there are two little links, and then the handle, and then the pin, which goes through all of this. I'm going to go ahead and shade the pin just so you know that it's the pin. And so we have two links, and we have a setup that looks like this. This is a case of double shear. And so we know that when we have double shear, the formula for the average shearing stress is equal to P over 2A, since there are 2 links. And so we're going to go ahead and start off by trying to find the area here. And so to do that, our formula is going to be pi over 4 times the diameter of the pin squared. And they give us the diameter up here, which is 16 millimeters. So pi over 4 times 16 squared, which is equal to 201.1 millimeters squared. And so now we need to find the force that's going through this pin, which is, we're going to actually need to draw a free body diagram in order to find this force. So I'm going to go ahead and draw. This is the top arm right there. I'm going to go ahead and put some coordinate axes on there. There's our positive x, positive y. We have the force P going up. There's a force from the link BD, so I'm going to call that FBD. And then we have a force from the link CE, so I'm going to call that FCE. And we have our, back up on the picture at the top, we have our distances here. And then we have point A, B, C. So what we can do is we can, since we need this force here, force BD going through point B, we can take the moment at point C and just that'll just cancel out this force right here since the distance is 0. So we can do the sum of the moments at point C, set that equal to 0. And then our distance is 0.4. This is going to be for the force FB. And then our distance times the force, which is FBD. And that's going to be a positive moment. And so then the force P will cause a negative moment. So we're going to have a minus. Our distance is 0.65 meters. And then the force P is 22 kilonewtons. They give us that in the top up here. I'm going to go ahead and change that to newtons just to make it a little easier, which is 22,000 newtons. And just keep everything in newtons and meters, which gives us that the FBD is equal to 35,750 newtons. So that's our force in the equation, the average shearing stress equation. That's our force P. So plug into there. And then we also have the area. So just plugging this into the formula. I'm going to go ahead and rewrite the formula. Our force is 35,750 newtons. And then the area is 201.1 millimeters squared. And we know that 1 newton per millimeter squared is equal to a megapascal. So average shearing stress is going to be equal to 88.9 megapascals. And that's it for this problem.